The following content has been provided by RWTH Aachen University.
So there's a final way of doing hardware prototyping or kind of combining hardware prototyping with your own sort of smart input, and that is called the Wizard of Oz. Quick show of hands here. Who knows what the Wizard of Oz is? Okay, so tell me about what's the Wizard of Oz about?
You mean like
The movie, yeah.
Okay, there's this girl, Dorothy, who enters a fantasy world,
Mm-hmm.
and there's this big wizard who is very famous, and she goes to him because she wants to get back to Kansas, where she's actually from. And when she arrives there, it's just a man behind the curtain.
That's just the man behind the curtain. Exactly. So the story basically is about a very powerful wizard that actually doesn't exist. It's just a little guy who's pulling strings and making this big, figurine move. That's where this technique got its name from. The idea is that you, as the designer, you're the powerful Wizard of Oz, and you're pulling strings, and you're making a system move and be very impressive, although really you are controlling it behind the curtain. Here's an example. Back in the days when I think I have an example of this. Let me see. Yeah. So here's how this works. Back in the days, IBM was experimenting with voice recognition. They wanted to basically see what it would be like to do text editing with voice recognition. But this was 1980 something. So voice recognition wasn't really working well yet. It was very, very basic. You couldn't use it in real time. So what they did is basically this is the user. He was sitting there in front of a microphone and a computer screen, and he was basically voice dictating a letter, including things like, delete last word and stuff like this. Behind the curtain, invisible to this guy, so in fact this wall was much higher, right? These guys were in different rooms maybe even, was this guy here who was sitting there next to the speaker. He could hear what this person was saying, and he would type in the stuff that was being said. And he would type it in here, and it would appear again on this screen. So for this user here, it seemed like he was dictating into the microphone, and the stuff was appearing on his screen. In reality, he was basically just dictating it to this guy who was typing it in for him. That's exactly how Siri works, by the way. There's this giant army of people who are typing in everything you say, and then no, just kidding. But they were basically trying to figure out how to do a good interface with Siri back in the days before they could even do real voice recognition in real time in good quality, right? And because the technology wasn't available, they used Wizard of Oz. They just used the human smartness, the human intelligence, to replace something that the computer couldn't do yet at the time. The cool thing about that is that you can test a new technique for interaction and design a good interface and figure out how good interfaces should work with this new technique, like voice recognition, before that technique is actually ready for prime time in consumer products. So you can be ahead of the curve with your research, with your design, before the actual thing is in the engineering department and gets put into actual devices, which is nice. So many times the wizard, which would be this guy here typing in the things here, is not visible, right? He's behind the curtain in a different room or something. Sometimes he's visible. The important thing is that the interface itself has some part that requires an intelligence or a smartness or an algorithm that you cannot provide at the time, at least not at a reasonable price. So it's great to add simulated functionality, very complex, mostly vertical, right? For example, the whole voice recognition here. Or testing futuristic ideas, like I said, the voice recognition editor from IBM in 1984. So finally then, the question is, what do we do with a prototype? There's a couple options we have what we can do with our prototype. The first thing is we can throw it away. And throwing away the prototype makes sense, and that's perfectly fine. Like, if you made a paper prototype, you've tested it with users, you've figured out what you did wrong, what you should change, you put that away, right? You don't need to build on it anymore. Even a software prototype, if you built one and it served its purpose, you've made your decisions, like the Keynote prototype that I showed you for the computer science department website, I don't need that anymore. I can move on and then go to the actual fully developed system, and I'm not using this anymore except to inform the design of the next stage. Sometimes you can stick with your prototype, tweak it a little, change it, expand it, make it a little better, and run another test to see whether you are on the right track. And your prototype might grow with you. It may become your final product. But that's a slippery slope. So I'll be careful about that, because oftentimes you then inherit some of the shortcomings of that prototyping technology that aren't good for the real system. Like, when we, for example, deployed the WorldBeat system, we kind of made that mistake, if you like, of actually using this for the final system. And yes, it was great because we didn't have to re-implement everything that we'd done in MaxMSP. But like I said, MaxMSP was also difficult to manage and to maintain as an actual software product. And that's the biggest problem. Most of the prototyping techniques are done for exactly that, prototyping. They're quick, they have fast turnarounds, immediate feedback, and so on, but they are usually not production strength technology. So that's something that you need to just be aware of.
This content was provided by RWTH Aachen University.